Welcome to this YSL tutorial. In this video we're going to talk about custom collections in Excel VBA. We'll begin the video with a quick explanation of what collections are, mentioning some of the built-in existing collections before we show you the custom collection object. We'll explain how to declare a variable which can hold a reference to a custom collection, and then how you can add items to that collection once you've created an instance of it. We'll talk about a couple of different ways of referencing items in a collection, as well as showing you how you can process the entire collection by looping over the items in it, using a standard for each loop. We'll highlight one particular problem with untyped collections, and explain one thing to watch out for when you're using those collections, before the final part of the video will explain how you can use a custom class module with a collection. So if you've defined your own particular class of object, you can then create instances of that object or that class and store those instances in a custom collection. The very last thing we'll cover in the video will explain how to extend the scope of a collection so that you can reference it even after a subroutine has ended, so it makes it a public collection. So there's a few things to do. Let's get started. Excel VBA has many built-in collections, each of which contains a number of objects of one particular type. So for example, there's a charts collection, which contains individual chart objects. There's a workbooks collection, which contains individual workbook objects. There's also a worksheets collection, which contains, as you probably guessed, individual worksheet objects. Each of these collections, as well as having a number of unique methods and properties depending on the type of collection and the type of object in it, they also have a set of common properties and methods, such as the add method. I can choose to add an object to the worksheets collection, which would add a worksheet object. I could also say workbooks.add, and that would add a workbook to the workbooks collection, and indeed charts.add would add a chart to the charts collection. There's a count property, which is common to every collection as well, so if I want to find out how many items there are in the worksheets collection, I can ask to display the worksheets count property. And I'd have to display that somewhere, so I'd use perhaps a message box, or print the value to a cell or to the immediate window using debug.print, for example. So I can say debug.print worksheets.count, and that would tell me how many items there are in that collection. There's also an item property for each collection, and that property allows you to specify or reference an object within the collection. So if I said worksheets.item, and then open some parentheses, I can then reference an individual item in the collection, either using an index number, such as the number 1, which would be the first item in the collection, or I can also often use a unique key, which is usually the name of the object. So for a worksheet, it would be the sheet's name. When I've referenced the object, I can then apply methods and properties to the individual object in the collection, such as select for the worksheet. Now, as well as having all of these built-in collections, some of which work in unique ways, VBA also provides you with a generic collection object. And you can use this generic collection object to create your own collections. And this video is going to teach you how that collection object works. To begin using a custom collection, we need to declare a variable that can hold a reference to it. So I'm going to start by creating a new subroutine, which I'm going to call create, or creating custom collections. And in that subroutine, I'm going to declare a variable which I'm going to call my collection as a collection. So you'll see this collection listed in the IntelliSense list as a class. Once I've declared a variable which can hold a reference to it, I can then create a new instance of the collection class. So I can do that by saying set my collection equals new collection. And at that point, I can then start using the methods and properties of the collection object. My collection object behaves like a very simple built-in collection, so it only has a very small limited number of methods and properties. If I reference my collection and then type in a full stop, I'll see that it has a list of 4 basic methods. I have an add method, like we saw for worksheets and workbooks previously, a count method this time rather than a property, which tells me how many items there are in the collection, an item method, which returns an item from it, and the remove method, which we didn't display before, but this allows you to remove an item from a custom collection. So before we can do anything really useful, I guess we need to start adding items into the collection. So let's have a look at how the add method works first. Now technically I can add anything that I want in VBA terms into my custom collection. So it could just be a simple string of text, or a number or a date, or it could also be a reference to another type of object altogether, such as a worksheet or a chart. For this example, I'd like to add a couple of worksheets to my custom collection. So I'm going to use the add method and then type in a space to see the tooltip. And it shows me there are 4 parameters, although there's only one compulsory one, which is the item parameter. So that is the actual value that I want to store or pass into my collection. If it was a simple string of text, I would simply type in the string. If it was a number, I'd just type in the number, for example. Because I want to pass in a worksheet or a reference to a worksheet, I need to create a reference to it. So I can do that in a number of different ways. I'm going to use a fairly traditional standard way of referencing a worksheet. I'll reference the worksheets collection, then open some parentheses and some double quotes, and say sheet 1, close the double quotes and close the parentheses. On the next line, I could do that again. I could say mycollection.add, and I could say worksheets sheet 2, for example, and that would add in a second worksheet into my collection. So adding items is relatively straightforward if you're just going to pass in the item or the value that you want to store in the collection itself. Now that I've added some items to my collection, I'd need to be able to reference them if I want to do anything useful with them. So based on the way that I've added my items to my collection so far, I can reference them based on their indexed position in the collection. So custom collections have a 1-based index of the items stored in them. So currently worksheets sheet 1, the first item I added, has an index position of the number 1, and the second item has index number 2, and so on. So one way to reference an item based on its index would be, let's say for instance I wanted to just show the name of the object stored in that first position. So I would maybe perhaps debug.print my collection dot, and then I could use the item method to return a reference to an object. So .item, open some parentheses, and then pass in the index number of the item you want to refer to. So I say .item1, then I could say .name, for example, which would access the name property of whatever object was stored in index position number 1 in my collection. Now if I display the immediate window, either using the view menu or the keyboard shortcut Ctrl and G, and then if I run this subroutine, I'll see the name of the first item in my collection printed to the immediate window. If I passed in index number 2 instead, and ran that subroutine again, I'll see the name of the item at position number 2. If I try to index or reference an item at position number 3, well there isn't one at this stage, so if I try to run this code, I'll get a standard runtime error, which will fail when I try to reference essentially an object which doesn't exist. Now, using the item method is one way to achieve this, but actually the item method is slightly redundant. I don't need to use the item method to refer to an item in a collection. It's similar to how we've seen previously. We could reference worksheets, for example, by saying worksheets, open some parentheses, and then the number 1, rather than worksheets.item number 1. So if I wanted to reference the first item in my collection, I don't actually need the item method at all. What I can do instead is just say my collection, open some parentheses, type in the value of the index, close the parentheses, and then refer to one of its properties or methods. So if I run this subroutine again, I'll see sheet 1's name get printed, and then again number 2, that will print out sheet 2's name. Now although referencing an item in a collection by its index number works, it's not a very convenient way to do it, particularly as you can insert more items in a collection and the index positions of other items might change. So more typically you'll want to create some kind of unique key or name to reference an object, and we can do that using the second parameter of the add method for a collection. So after the reference to the object that I'm adding into my collection, what I can do is type in a comma, and that will display the key parameter. Now the key parameter is any alphanumeric string, so if I open up a set of double quotes, I can call this object essentially whatever I want, as long as this name does not already exist as a key in the collection. So I guess a convenient thing to do at this point, although it's a little bit redundant I suppose, but a convenient thing to do would be to use the name of the worksheet. I know that the worksheet names must be unique in the worksheets collection, so that means they'll always also be unique in my custom collection. So I can do this again for the second worksheet that I add, and then this provides me with another way to reference my objects. So rather than referencing them by index number, I can say sheet 1 or sheet 2, and that will print out the name of that named item in the collection. Now I get this, I've used the same name as for the object name, so the worksheet name is called sheet 1, and the item in my collection is also called sheet 1. These do not have to be anything like the same names at all. I could maybe use a slightly abbreviated form of this. I could call this WS1, and sheet 2 could be WS2. If I wanted to reference the object in my custom collection then, its name isn't sheet 1, its name is WS1. So if I was to step through the routine at this point, and we'll see these items get added to the collection successfully, when I print out the name of WS1, the name property refers to the name property of the worksheet. So I'll see down here again at the bottom, I'll see sheet 1 appears. So that's using the key parameter to specify a unique name for an item that you add to your collection. Another useful thing to be able to do to items in a collection is to loop over all of the items using a for each loop. So just like in any other standard collection built into Excel VBA. So I'm just going to clear out the immediate window at this point, and I'm going to go back to my subroutine and declare a new variable which will allow me to loop over the collection. So I'm going to call it dim my object as, and then depending on what you've actually added to your collection, you could choose, in my example, I could choose a worksheet class, because I know that the individual items I've added to my collection are worksheet objects. So the variable I would use can hold an individual worksheet object to loop over the collection. If you weren't comfortable or confident of which types of items you'd added to your collection, so for instance if you'd added a combination of charts and worksheets and I don't know, workbooks and strings of text, you could mix and match the items in a collection. They're untyped collections. Then you might need to use the more generic object type. So that would allow you to loop over any type of item stored in your collection. For my example though, I know that the items in my collection are worksheet objects, so I'm going to make mine as explicit as possible. What I can then do is, rather than just printing out the value of one of the names of one of the objects in my collection, I can loop over the entire collection with a for each loop. So I can say for each my object in my collection. I'll write out the end of the loop, which will be next my object. Next my object, or just next if you prefer. And then what I can do is say debug.print, and I could say my object dot name, for example. So if I step through this routine at this point, we'll add the two items to the collection. Now my loop is going to process every single individual item in that collection, and it will print out the name of the first item, name of the second item, and as soon as it runs out of objects, it will stop the loop and continue with the remainder of the subroutine. So the for each loop works with custom collections just in exactly the same way it works with built-in collections. One of the big potential problems with looping over a custom collection is that you might not know precisely what types of objects are contained in the collection. It could be a mix of different object types, so there's absolutely no guarantee that the type of object you're looping over at any one point has a name property, for example. So just to demonstrate how that would work, if I was to, say, add a workbook object into my custom collection, I could say my collection.add, and I'm going to say this workbook, and I'm going to give that the key, I'm going to call it WB1. And rather than using the worksheet type to loop over my custom collection, I'm going to revert this back to the generic object type. So this will work at this stage because I know that both a workbook and a worksheet have a name property. So if I step through the routine, I can add all these different types of items into my collection, and I can loop over them all, and because I know that each object type has a name property, it will successfully work. However, if I tried to use a property which only exists for a workbook or for a worksheet, for example, then this would fail. So there's a visible property for a worksheet, for example. So if I wanted to print out whether the worksheet was visible or not, I could say my object.visible. And then if I use the F8 key to step through this one, I'll find out that the property for both the first two worksheets is -1, but then for the workbook, this will fail because a workbook object does not have a visible property. So this is one of the big dangers of using custom collections. There's no limit to what sorts of things you can put in them. So you need to be slightly careful about controlling what items you add. In a later video, we're going to talk about how you can use class modules to create strongly typed collections. So it restricts you to only adding certain types of items into your custom collections. But we're going to save that for another video. As I've just mentioned the idea of class modules to create strongly typed collections, it's worthwhile mentioning that you can add objects of a custom class into your custom collections as well. So if you had a class module which defines a type of object, you can add instances of that class into your custom collection. So in this workbook we have, for example, we have a basic list of films. So we could design a very, very basic class which has some properties of a film object. So let's very, very quickly do that. If I right click in my Project Explorer and I choose to insert a class module, I'm going to call the class a film. If you want a more detailed class module example, there's another video in this series that explains in much more detail how to go about doing this. So I'm only going to do some very, very basic things here. I'm not even going to create some full property statements. I'm going to create some very, very basic class fields by declaring some public variables in my class module. So I'm going to have a film ID as an integer, and I'm going to have a public film name or title, perhaps I'll just call it a title, as a string, and I'll have a public release date as a date. And what else have we got there? Maybe a length property for the length in minutes. Let's have just that one. So let's have a public length as integer. So it's a very, very basic class with a few simple fields. But what that means I can do is if I go back to another module, I'm going to create another new subroutine for this. So I'm just going to remove my immediate window for the moment and create another new subroutine. So I can say sub using custom classes. So in here I can create a variable to hold a collection of films. So I can say dim films as collection. And I can also say dim f as film. If I create a new film object, then I can say set f equal to a new film, and I can set various properties of that object. So I can say f dot film ID equals 99, f dot title equals I don't know what's a new film that's out at the moment. Teenage Mutant Ninja Turtles. I have no intention of seeing that film whatsoever. It looks absolutely awful, but it just sprung to mind because I saw an advertisement for it just recently. F dot release date. I think that comes out tomorrow. So today is the 16th of October. So I'm going to put in the release date as the 17th of October 2014. And then the film's like, I have no idea how long it is. Hopefully quite short. So as I say, it sounds dreadful. Let's say I don't know, 100 minutes, for instance. Now that I've got that object created, what I could do is also create a new instance of my films collection. So I could say set films equals a new collection. And then further on down the list, what I can do is I can say films.add, and then the item would be the film object stored in my variable or referenced in my variable, and the key I would probably say f.filmid, because I tried to make sure that those were unique. So that's adding a unique an item of a custom class into a custom collection. Very, very simple idea, but it is a common use for custom collections. For this particular example using a custom class, rather than adding a single unique item into the collection, what I could do is loop over the collection of all of my films, generating a new object for each one and adding each one into my custom collection. So just to show briefly how that would work, what I'm going to do is head back to the VB editor. I'm going to take away this section of code here, where I'm setting unique specific properties for this new film. I'm going to take away the set f equals new film as well. What I need to do is loop over a collection of range objects. So I'm going to have another variable which I'm going to say dim, I'm just going to call it r for convenience, as a range. And after I've created my new collection object, what I'm going to do is I'm going to say, I'm going to make sure that I'm on sheet 1 first. So I'm going to say sheet1.select, and then I'm going to say for each r in range a3 to range a1.endxl down. So what this will do, if you haven't seen previous videos where I've used this technique before, this will loop over all of the cells between cells A3, so that's the top cell that I will look at, and range A1.endxl down, so that's the cell that's at the end of the list from cell A1 in the worksheet. So A1.endxl down is like clicking on cell A1, holding down the control key and pressing the down arrow key. So essentially I will loop over all the cells between A3 and A15, but if I had more rows in the list, it would loop over more cells. So back to the VB editor, I'll have the next R statement to make sure I don't forget to do that. And what I'm going to do for each individual cell in that list, I'm going to set f to be equal to a new film. And I'm going to set its various properties. I'm going to say f.filmid equals r.value, and I'm going to say f.title equals r.offset 0,1.value, so that's the value of the cell 1 column to the right, and then f.release date would be, I'm just going to cheat here slightly and copy and paste some things, so I'm going to copy r.offset 0,1.value and change that to r.offset 0,2.value, and then finally f.length equals, and I'm going to paste that in again, and r.offset 0,3.value. What I can finally do with the film, once I've set its properties, is I can say films.add f, and again I'm going to use the f.filmid as the key, the unique key for the item. I could also use the film's name as well, the title. I'm pretty sure that in this list all my film names are unique, but that might not necessarily be the case, so let's use the title instead for this example. What I then want to do is, before I move on to the next iteration of the loop, is I want to set f to be equal to nothing, so the next time I go around I can create a new instance of a film object, and then they will all be added into the films collection by the end. Once I've done that, I'll need to use some sort of, or at least demonstrate that all the items are in the collection. So very quickly I'm just going to say debug, in fact message box instead of a debug.print, let's use a message box, and I'm going to say there are and films.count and films in the collection. So it'll tell me how many I've actually added. So if I use this routine, if I use the F8 key to begin stepping through, just so we can see that it's going to first of all choose our value is number 1, so index number 1, this is the Avengers and the release date and the length and so on, that gets added into my collection, then f becomes nothing, and then I create a new one, so this next one is item number 2, and it's the Dark Knight Rises, and so on and so on and so on and so on and so on. So if I just press F5 to run this all the way through to the very end, it'll tell me there are 13 items or 13 films in the collection, because I've added 13 films from this list. If you're writing loops like this to populate a custom collection, it's fairly likely you'll want your collection's lifespan to be longer than the end of the subroutine. So currently, because we've declared the variable within the subroutine, it's destroyed as soon as the subroutine ends, and any items in the collection are lost as well. So we can get around that problem by making this variable a public one. So if I cut my variable declaration from this subroutine and instead declare it at the top of the module, or indeed in another module, if we're using the word public, we can create this collection anywhere at all, or declare this collection anywhere at all. I'm also not certain now when I want my collection to be created, so what I'm going to do is I'm going to create an auto-instancing variable by adding the new keyword to the declaration. So that means that the creation of the new instance of the collection is handled automatically by the variable. If we encounter the word films in code or a reference to films in code, if it already exists, then the collection won't be recreated, but if it doesn't exist, a new instance will automatically be created. That means that I can also remove this line, and in fact I need to remove this line from this subroutine to make sure that it doesn't continually create a new instance of that class each time. So what we should then do is have another subroutine which we can use to test that the public collection works. So I'm going to have a subroutine called test public class, or public collection even. And in there we could do a variety of things. We could simply say message box, and what could we do? We could reference an item in the collection, so we could say films, open parentheses, let's say I want to refer to the 5th item in the collection, and I want to show its title. So I know the items in the collection are film, or objects of the film class, so there's a title property that I can work with. I could also loop over the items in the collection as well, so I could have a dim f as film in this subroutine, and as well as showing a single message, I could say for each f in films, next f, and I could say debug.print f.title, and other bits of information as well. If I had any useful methods in my film class, I could apply the methods to the films, and so on and so on. So just to show you that this will work, if I run this first subroutine to generate my collection, there are 13 items in it, and then I can run any other subroutine which will make more sense if I can display the immediate window as well. So if I view immediate window, I'll just clear its contents for the time being. And I can step through this routine. I'll see my first message box, which is the name of the 5th item in my collection. And then if I step through the loop just for the first couple of times, you'll see that it processes the individual items in the collection. If I press F5 to run all the way through to the end, that's the complete collection looped over. So that's just a way to make your sort of extend the lifespan of your collections. You can declare them as public variables and then populate them in one subroutine, in one module, and extract information from them in another subroutine or another module. If you've enjoyed this training video, you can find many more online training resources at www.wiseowl.co.uk.